All right, welcome to The Explainer. Today we are diving into a genuine cosmic detective story. We're on the hunt for a star that, well, it just shouldn't exist. It's a suspect that seems to be breaking the fundamental laws of gravity, and we're going to try and figure out how.
So let's just jump right in. The whole mystery really boils down to this one simple but totally baffling question. How can a star possibly be too big for its own orbit? I mean, seriously, think about that. It's like trying to park a bus in a spot made for a scooter. That's the kind of impossible scale we're talking about here.
Okay, so meet our prime suspect. What you're seeing here is a pulsar system called M62B. Now, the pulsar itself, that's just a tiny, super dense, spinning corpse of a star. But it's not the problem. No, the real troublemaker is its partner, the companion star orbiting it.
To really wrap our heads around this, we've got to look at what scientists are actually seeing versus what physics tells us should be possible. And believe me, this is where things get, well, really, really weird. It makes you start to question the rules themselves.
So here's the central conflict, right? On one side, you have all this evidence from the star's light, and it's telling a very clear story. It says the star is being stretched into this kind of egg shape by the pulsar's insane gravity. It looks for all the world like it's literally overflowing its own gravitational leash, what astronomers call a Roche lobe. You can picture it like a glass of water filled right to the brim and then spilling over. But, and this is the absolute kicker, when astronomers actually do the math, when they calculate the star's real size based on how bright and hot it is, they discover it's at least 3 times bigger than its Roche lobe. It's just physically too large to fit inside that gravitational bubble. It's like the overflowing water glass is somehow 3 times bigger than the glass itself. It makes no sense. It shouldn't be there, but it is.
So, how in the world is this possible? To even begin to find answers, we have to pull back. We have to look at the neighborhood, the environment where this impossible star lives. Let's go investigate the cosmic crime scene.
Okay, so our mystery is taking place inside what's known as a globular cluster. The easiest way to think of this is like a giant, ancient, and incredibly packed city of stars. We're talking millions of stars all crammed together, held in a tight ball by gravity. These things are some of the oldest structures in the entire universe. And we're not just in any old star city. This is Messier 62, M62 for short. And let me tell you, it is a rough neighborhood. It's so close to the chaotic center of our own Milky Way galaxy that the galaxy's gravity is literally tearing it apart, pulling it out of shape. This kind of super dense, violent place, it's the perfect pressure cooker for forging the weirdest, most exotic star systems you can imagine.
And yeah, that chaotic environment has created a whole menagerie of strange things. M62 is actually famous for its bizarre zoo of pulsars, and if we want to get to the bottom of our mystery star, we absolutely have to understand them first.
So M62 has at least 10 of these things, and they're called millisecond pulsars. And the best way to describe them? They're basically cosmic zombies. You have these ancient, dead cores of stars that should be quiet, but instead they get spun back to life. They start whirling hundreds of times per second because they're stealing material from a nearby partner star.
Now get this is the crucial bit. Every single one of the 10 known pulsars in this cluster has a partner. That's not normal. It's actually highly unusual, and it throws a real wrench in the models astronomers use to figure out how these clusters grow. It tells you something about M62. It's a place where having a partner, even a violent one, is just the way things are.
And what a lineup it is. It's a real rogues gallery. You know, these systems often get named after spiders, which is kind of creepy but also fitting because of the way the pulsar just violently preys on its partner. So you've got black widows with these tiny, lightweight companions they're devouring. And then you have our main suspect, M62B. It's a redback, a type of system with a much bigger partner star. And that's where we find our impossible object.
Okay, let's get back to the case file. It's time to lay out the clues. We've got 3 key pieces of evidence that, when you put them all together, paint this incredibly confusing picture.
Clue number 1 comes to us from the Hubble Space Telescope. What you're looking at is called a color magnitude diagram. Just think of it like a lineup of stellar fingerprints, where you plot every star's brightness against its color. And right away you can see our suspect. That little triangle there, it just doesn't fit in. It is way, way redder than any other star around it with the same brightness. I mean, that is a massive red flag. All right, clue number 2, the star flickers. Its brightness isn't steady. It pulses up and down in a perfect rhythm that matches its 3.5-hour orbit exactly. This pattern, this light curve with 2 peaks every single orbit, is the textbook signature of a star that's being squeezed into an egg shape.
This is our smoking gun. This tells us the star has to be overflowing that gravitational boundary. And for our final clue, we turn to the Chandra X-ray Observatory. Clue number 3. The whole system is glowing in X-rays. That's a dead giveaway that something violent is happening. It points to a high-energy collision where the insane wind blasting off the pulsar is just slamming into the gas that's being ripped off its companion.
So let's just step back and put this puzzle together. We have a star that looks, acts, and feels exactly like it's overflowing its gravitational bubble. All the signs are there. But, and here's the quote from the actual scientist who studied it, when you calculate how big it actually is, it is way, way too large for that to be possible. The evidence contradicts itself.
So, what's the verdict? With all this conflicting evidence, how do we solve the case? Well, here's the thing. The truth is, this cosmic detective story is still wide open.
Right now, astronomers have pretty much narrowed it down to 3 possible explanations. Theory 1, mistaken identity. Maybe this whole system isn't even in the M62 cluster. If that's true, our distance measurement is wrong, and so is our calculation for its size. Theory 2, it's an optical illusion. Maybe the light we're seeing isn't all coming from the star itself, but from some bizarre energy interaction with the pulsar that just makes it look bigger than it is. And Theory 3, a cosmic photobomb. We could actually be looking at 2 stars perfectly lined up from our point of view, and their light is blended together, making one look impossibly huge.
And you know, what this really shows us is just how much we're still figuring out about the universe. Puzzles like this one are so important. They remind us that science isn't about having a textbook full of answers. It's a messy, dynamic, ongoing investigation into the great unknown. And that really just leaves us with one final kind of mind-bending thought. We've found a star that seems to exist in a place it physically cannot fit. So it just makes you wonder, what other impossible things are out there waiting for us? What other cosmic rules are just waiting to be broken?